section 9.1.RA-8. In a trial of 300 patients who received 10 milligram doses of a drug daily, 54 reported headache as a side effect. Use this information to complete parts A and B below. We want to verify that the requirements for constructing a confidence interval about P are satisfied. Well, the first thing is that each trial is independent, and it is safe to assume that 300 is less than the 5% of the population. So now what we want to do is we want to use the point estimate to confirm the following, which is greater than or equal to 10. So we need to find out what the point estimate is. And recall that the formula for the point estimate is equal to x divided by n. So in our problem, we know that x is equal to 54, and the value of n is equal to 300. So in order for us to figure out the point estimate, we're going to take the value of 54 and then divide it by n. So therefore the point estimate is going to be 0.18. Okay, so now that we've done that, now what we want to do is now we want to check to make sure and confirm that n times the point estimate times 1 minus the point estimate is going to be greater than or equal to 10. So we know that n represents 300. We'll multiply it by the point estimate, 0.18, times 1 minus 0.18, and we want to confirm that that's greater than or equal to 10. So we end up getting 44.28, and that is greater than or equal to 10. And so therefore we can say that since 44.28 is greater than 10, then the requirements for constructing a confidence interval about P are satisfied. Okay, now let's take a look at part B. Part B, they want us to then construct and interpret a 99% confidence interval for the population proportion of patients who receive the drug and report a headache as a side effect. So let's go back to the definition. So when you're constructing a 1 minus alpha times 100% confidence interval for a population proportion, you're going to suppose that a simple random sample of size n is taken from a population, or the data are the result of a random experiment where you have 1 minus alpha times 100% confidence interval for P is given by the following quantities. We have a lower bound, and then we have our upper bound. So far, we know that we have our point estimate, which is 0.18. We also know that the value of n is equal to 300. And so what we want to be able to do is look for the critical value of z alpha divided by 2. So in order to do that, we know that we have 99% confidence. So we first need to we need to take 100% and subtract the 99%, which gives us 1%, which represents 0.01. Okay, and so this is actually equal to alpha. So we're going to take z, and then the alpha is going to be 0.01, and we're going to divide that by 2. So what is 0.01 divided by 2? We know that 0.01 divided by 2 is going to equal 0.005. So if you recall here, whenever we have z, this tells us that the area to the right is 0.005. We want to find that z-score. But what we want is, remember our z-scores are everything to the left. So we're looking for 1 minus 0.005. Okay. So we can either use 1 minus 0.005, or we can say that this is 0.995. Okay, now we're going to use technology. We're going to use StatCrunch and the calculator to be able to find this z-score. So we know that if we use INV norm, we know that the area to the left is 0.995. We know that we have a mean of 0 and a standard deviation of 1. So let's go ahead and put that in our calculator. So we have second distribution. We're going to go to INV norm. We're going to put in the area of 0.995. We have our mean of 0 and our standard deviation of 1. And so therefore, let's go ahead and so here you can see that we get a z-score of 2.58, which is the critical number that we need to use. So if we want to use StatCrunch to find the z-score, okay, we would just use our calculator, the normal calculator, and we know that the mean is 0 and the standard deviation is 1, and we want to find the z-score that's to the left of that by using the area of 0.995, and therefore it's going to give us the same z-score that we used for the TI-84 calculator. So either or you can use to find the z-score. Okay, so now we know that z alpha divided by 2 here is going to equal 2.58. So now what we're going to do is we want to find the lower bound. So I'm going to abbreviate that as the lower bound. And so if we look at our information there, we want our point estimate to be 0.18 minus 2.58 times the square root of 0.18 times 1 minus 0.18 divided by the value of n, which is 300. And when we want to find the upper bound, it's going to equal 0.18 plus 2.58 times the square root of 0.18 times 1 minus 0.18 divided by 300. Okay, so let me show you how we do this in the calculator. So if we take this value here, we can kind of work using order of operations. We're going to work with inside the square root sign. So we're going to take this 0.18 and we're going to multiply it by 1 minus 0.18. Okay, so now that we get the numerator, we're going to divide it by 300. Okay, so there is our answer, but then we got to take the square root of that. So we're going to hit second square root, and then we're going to use the answer. So a lot of your calculators are going to say answer. So you hit second ANS, which is the answer. So we take the square root of that, and now we have this number. Now we need to multiply it by minus 2.58. So we're going to multiply it by negative 2.58, and then we're going to add the 0.18. And so we're going to round it to 3 decimal places, so that gives us 0.1223. So we get 0.1223, I believe. Yeah, so I'm sorry, 0.123. Okay, and if we do the same thing over here, again, we're going to take the 0.18, multiply that by 1 minus 0.18 Divide that by 300. We're going to take the square root of that answer. We're going to multiply it by 2.58. And then we're going to add the 0.18. So rounding that to 3 decimal places, we get 0.237. And so therefore this represents our lower bound. This is our upper bound. So we write this in a confidence interval. So the lower bound is going to be 0.123 and the upper bound is 0.237. So there is the confidence interval. So now we want to formally write this conclusion, and we can say that one can be 99% confident that a proportion of patients who receive the drug and report a headache as a side effect is between 0.123 and 0.237.